Guys, so when you've been programming in Scala for 9 years, there's probably no other way to develop your skills than to come up with some niche use cases for it. So our next speaker is an experienced Scala developer and a functional programming fan. So he will show you how you can use Scala for front-end programming. And what's more, he will use for that a less popular library called Calico. So that's, I guess, a really original equation if you add up Scala plus front-end and plus Calico library, which gives you a unique approach to functional programming. So do stick around, because I also heard there's going to be an artistic element in this talk. So please guide our speaker and give him a big warm applause for lead engineer at SiriusXM, open source contributor, Scala-themed YouTuber as well, so you can check him out. And I asked him about his fav game, because this is a thing I asked all our speakers. He loves Assassin's Creed too, so we can talk about that as well. Jakub Kozłowski, give it up for him.
Thank you, Ola, for the introduction. Thank you to the organizers for having me on a pretty short notice. Yeah, okay, the slide layout was strange. Yeah, I'm here to talk about Calico. I'm not sure about the timer, but yeah, let's just try to make it. So this is the functional front-end library you didn't know you needed, because we have a couple of front-end libraries in Scala that are being used, some of them to a wider extent, some of them to a smaller extent. I don't think this one is getting enough attention for what it's doing and how it's doing that. So I think you deserve to know. I just want to have a word of warning. Of course, there's a missing picture here, whatever. This talk is optimized for replay value, which means basically it's just going to be fast and I'm not going to explain things very well sometimes. But the idea is that you can always catch up on the missing things. If I assume you know something and you don't, if you can rewatch the recording later, catch up, and then return. So please return to the talk, to the resources. You're going to need it, probably. So what's Calico? I think it's a truly functional front-end library for Scala.js. By truly functional, I mean that there's nothing in the library that would break or make you break referential transparency in your code, which may seem like a small detail, but it's something that you notice is really important as you build and scale your application beyond a certain size. You want all the pieces to be predictable and compositional, and all the magical words you can imagine. You want things to stick together and not break up in strange, unexpected ways. So even something like creating a variable to be displayed in your UI, that should also be that should also follow these principles of compositionality and FP. And the way it does that is very simple. It just builds up on other libraries that have been doing this for years and years, like Casifect and FS2. Casifect is about 6 or 7 years old at this point. It just had a new major release in 2021, if I'm not mistaken. And it's a very stable ecosystem at the moment. So because this builds up on those libraries, you can benefit from all the greatness, all the tools that people have built, all the libraries in that ecosystem as well. The core idea of Calico is very simple. Every UI component that we create is a resource. What's a resource? Well, it's a thing from Casifect, and it's a data structure that encapsulates the lifecycle of a stateful resource, something mutable, something that has like a connection or like a file behind it. So we can create a resource by saying how to get it, how to acquire it, and then how to clean up after we're done using it. And we do this ahead of time. We just declare how to open and close it. It's kind of like if you were implementing the auto-closable interface in Java. You can make a resource from an auto-closable very easily, but it's functional, of course. And then when we eventually, we've made our resource, at some point we want to use it, so this will allocate the resource, do the use part, whatever we supply at that point, and clean up. And the main question we have to ask when we see something like this is, does it compose? Because things like try finally or try with resources in Java, they don't compose that well, because you just get this, you can see the same kind of pattern, this increasing level of nesting. And this does look familiar, doesn't it? So we want to avoid getting ourselves into such a situation. So of course, we are looking for something that will allow us to compose more nicely, like monadic composition, like flat map. And of course, this is something that we get when we use Calico, because, or when we use Cat resource, because it does implement these methods, flat map and map. So we can build our bigger resource out of smaller resources, and then at the very end, we can use it, which will allocate all the things in order, apply our use block, and then deallocate these things in opposite order, so that things that depend on other things will get cleaned up first, and the kind of root things that nobody else don't depend on anything else, these will be cleaned up last, when nobody else needs them. So that's how resource composition works. And the components in Calico are also resources. I've mentioned this like 7 times by now. But they're resources on steroids, you could say, which I've always found it a funny phrase, a funny expression. So we can flat map on the resources and build like bigger resources out of smaller ones, like we can use a div and a button in another div. But in Calico, we also have special syntax for something similar, which is to just pass other resources to the kind of constructor of a div or whatever element. And this has some semantic differences when it comes to the lifecycle of that outer div. But these differences are something that you'll have to figure out when you actually start using the library. I will not explain them today. And yeah, this gives us that block right here. This is actually powered by this code on the slide. This render here thing, that's just something I made up for the presentation just to make this actually work. It doesn't exist in the library. But OK, we have a component that's a resource. So what? How do we make it interactive? That's the important part. That's what we need from our application. So yeah, all the emojis are going to be like this. I'm sorry, it's just internet connection. We can add listeners to our elements. For example, to a button, we can add an on-click listener, and this takes an I/O. Of course, it does. It doesn't take just a side effectful function. We're in functional programming world, right? So yeah, we can trigger some event when we click, and of course, when I click, it does trigger that event. By the way, this is using some bleeding edge syntax. This does not exist at the moment in the released version of Calico, but it has been merged. It will be released, I hope, this week. There is some more powerful syntax that you can use. It's just more verbose, but yeah. Anyway, we can add listeners. We can listen to events, and you can also receive these events as a stream, FS2 stream, so we can do things like group by, chunk, whatever, all these manipulations on a stream of events, which I think is really cool, but probably not something you need for 90% of the time. Now, we can add listeners, but we can, and this seems like a core need for us, we can also get state out of the DOM. So something like an input box, when I type here, I want to be able to get that value and do something with it, right? Otherwise, my UI is not very interactive. So I'm here registering the onChange event. So when I defocus out of the input, it will call that callback. It will get the value of the input node, the input element, and do the flat map, and again, alert us with it. There's this special with self syntax, so it's kind of similar to useRef if you've used React. I don't know the view correspondent to it, but you get the idea. Like, it gives us a kind of callback. This is something that we can use to refer to the element that's being rendered. So kind of like a recursive fixed point kind of thing. But still, if you notice one thing here, we just have one element that's an input box, and we're only listening to like onChange events. It would be nice to be able to share state between multiple elements. So for example, when we have an input, we could maybe just gather inputs from it constantly, and when someone presses a button, then we would actually send that input somewhere. So that seems like sharing state. And how do we do that? Well, it's the same idea, the same construct that we will use the same as what people use in other cause effect applications, which is ref. The simplest thing ever in cause effect. So we have a data structure that encapsulates basically two operations. There are more, but this is like a simplified view. We can get a value in an effectful way, and we can update it. There's I/O involved because there is some mutable state right here, concurrent mutable state, and the abstraction of ref helps us deal with it. But still, we need I/O. What is more, if you're not familiar with ref, but you know what I/O is, creating a ref is an effect. It also returns I/O. If you don't understand why at this point, I have a great talk to recommend from Fabio Labella, Shared State in PureFP. It explains this idea very well. But long story short, in like a 5-second slide, which is going to take 5 minutes, if you have a ref that's created in an I/O, and you flat map on that I/O once, and then you use that ref multiple times, that will share the ref. This is the same variable, the same state that you're operating on, or the same pointer to some state, if I can use some dirty words. However, when you flat map on that effect multiple times, every time you'll get a different kind of scope of state. So it will not be shared at all. So this is probably something you should avoid doing. There are, of course, valid use cases for doing that if you want like 2 units of state. But in case we want to like update a number and get it, this is not the way. You want to do it in like 1 block, not 2 flat maps. So yeah, if you want to share this state, the scope that it exists, like is shared, is this. That's how you should do this. Now here, I'm just lifting my I/O of ref that I got from creating a ref to a resource so that it can compose better with other resources. But yeah, I just create a ref on the outside of my components, my elements, and then I am free to use that ref in my elements, in their callbacks. So for example, we have an input, which will fill that ref every time we have an input event, which triggers basically on every keystroke. We also have a button, which when we click it, it will get the value from that ref and then print it. So for example, if I type my name, it works. Magic. I acknowledge this is quite a lot of code for something as simple as this, but again, we're hoping to get the right mindset, the right principles behind this, and maybe not just the cleanest UI or the cleanest piece of code, the smallest piece of code. And still, we can store state in a ref. We can retrieve it on demand, like once when something hits, when there's an event. But what's also very commonly done in UI code, you just want to display the state like at all times, and whenever it changes, you want that to be reflected in your view. So how do we do that? Well, we cannot just put a ref into our div in any way like that. We need something more powerful than just a ref. We not only need to be able to get a value out of the ref at some point, we also would like to be notified when that value changes so that we know how to, when to update the view accordingly. And that is what Signal is doing from FS2. This is a simplified interface. So we have a get, just like we did in ref, but we also have access to a continuous or discrete stream of updates. Continuous just means that, well, it's not exactly a stream of updates. It's just like, I want you to give me some value of that signal all the time. Just like spam me with updates. This is not something you want to be using for UIs, because that way you probably just emit a lot of useless events when there's not a lot of changes. But there's discrete, which will give us updates every time the value changes. If there are many updates in a short period of time, you may still miss some of them. But long story short, like you will never miss the fact that something did happen, and you will always display the latest value from the user's point of view. So signals, how do we get them? They come in 2 flavors. One is when you have a stream, you can kind of capture it as a signal, which will always like hold the latest value emitted by that stream, which is why it's called hold. Or you can make a signaling ref. And this making one looks exactly like making a ref, it's just a different constructor. But then you have a signal and a ref in one value. So we have both get and set and update, and also the streams. So that's what's used most commonly. To create a signal from a stream, we can use hold and its other variants. There's like hold resource, hold zero, hold option. We have to provide an initial value in some of them. In the option 1, for example, we don't have to do it. And that, in this case, returns a resource, because when we hold a stream, that has to start a sub-process, basically, like a fiber. And then with up on it, again, we just combine resources to build a bigger resource, and we can create a div. All you have to do to insert like a signal into some element is just put it in, but it has to be a signal of string or something else. Like it could be a signal of resource, but I won't get into this. So yeah, this is actually showing the actual time that this site has been opened. This file has been opened. I mentioned this before. We can create a signaling ref, so both the ref and the signal in one go. And again, this we can map on a signal, so that's what I'm doing here. And I'm just like putting it, like throwing it into the button. So when I click the button, it will update with that state. Isn't that amazing? Okay, I know. But the slides are not so big anymore, not all of them, right? Signals can be used for more than just displaying state. For example, we can customize styles with our signal. So this is also a great exercise in showing like why this is purely functional, why there's referential transparency, because I have a val component and I'm using it twice. So in like, React world, this would be the same state, right? This would use the same state twice, but it's actually 2 different states. So voila, functional programming. And we have this magical operator here. That's something that you have to use when you want a signal to target an attribute on button. This is called style utter to just disambiguate from the style tag in HTML. But yeah, that's just one of the exceptions. Okay, and streams and resources, all of that. There's plenty of that in the DOM. Calico builds up on FS2 DOM, which is kind of like thin functional layer on top of just Scala.js DOM, the document object model. So this will wrap some browser things, basically. One of the things is mouse events. So what you're seeing here, the state, is the position of my mouse. That's all powered just by this code on the side. I think it's pretty cool. So again, another resource use case for hold resource. And I just want to point out one thing. When we inspect element here, you should see that maybe you don't see that. Maybe I can increase the font size. Okay, here. You can see that only like this element and its contents is being replaced. It's not like I'm replacing the whole thing. So this is like a nice thing from Calico here. Now, I just want to have some fun demos. So we have some setup here for keyboard events. We'll listen to down and up events, and we will be able to show the state of a particular key on the keyboard. So with all that, I can press K, and it will show us when it changes. There's some lag on the presentation, but I can see it instantly here. The cool thing, again, this is resource, and the resources have something like something called applicative composition as well. Because they're monads, they are also applicatives, which means we can traverse a list to a resource, and then combine that. This will give us, like multiple things that can be tracked independently. I want to point out one thing. There's no part traverse here because the resources themselves are being acquired sequentially, but once they're acquired, they run at the same time. So this is still kind of concurrent. You can do some funny animations here. I've been practicing. All right. What about something more complex? Maybe we want to put into our review on our components something like a WebSocket stream. Let's take a look. Here I'm using something called WebSocket Stream Client. This is an in-progress implementation of an experimental browser API, which is only ready in Chrome at the moment, which is why we have a fallback for WebSocket Client. What's the difference? The difference is this one has back pressure. So when you request some WebSocket messages from your server, well, normally you don't request them. Like in the WebSocket client in the browser, you just get spammed with events. So if there's a lot of things on the coming to you from a WebSocket server, your browser will die. This does not have that problem, as we'll see in a moment. So I'm connecting to an endpoint, and then I'm to WebSocket endpoint. I'm going to receive all the text frames from it, take the non-empty ones. This is all, from this point, this is all FS2, right? Nothing in these lines, well, except for the div and p. The rest is like, not Calico related at all. Just our usual FS2 library. And I'm doing some stream manipulation here. We are limiting it so that we only get like 10 elements per second. This is going to be 10 groups of 10 lines because of this. And we're putting that into a div with a paragraph for each line. Let's see what that looks like. There's no coincidence on the side. It's going to be called Shrek because we're going to stream the entire script of the Shrek movie on the next slide. And this is already running. This code that you're seeing here, this render here, that's already running on the next slide. However, it will not actually start the connection until the element is visible. So when I open the slide, it will do that. So this is the movie, the whole script. Now you'll notice why I did that metered 1 second by 10 is if I don't do that, if I just accept all the elements as they come in, when this slide compiles, you will see that it's very quick. Like it's just almost instant. So that's not very good to show. But one thing I do want to show is this super cool client. You can see that the tempo of these messages being like fetched from the server is basically the same as how I'm displaying it. So that works in Chrome. It doesn't work anywhere else. I just wanted to show you how cool this is. Now, we're almost done. I just wanted to move on to the demo now. The fun part. I was in Amsterdam a couple of months ago, and on a complete kind of like, this wasn't planned, I went to the Museum of House Music in Amsterdam. It's called Our House. And they have this machine right there, built by Red Bull and some musicians and technicians, I assume. And it's the world's biggest sequencer. And there are synthesizers on the right and left. Not sure if you can see that. There are some synthesizers in these kind of walled boxes. But all the things here, these are like light switches, which can be used to control what gets played on these synthesizers. So you can program some music onto these walls, and this will just play. And it's being displayed as a thing in the museum. So you can go there, you can program some music on it with friends or random people. And it's a very nice experience. I enjoyed it very much. I have a very short recording. I wish it was longer. I don't know why I didn't make more. So yeah. I just want to point out one thing. It has like 16 steps, I think. And you can see the flashing light on the top is like what was currently being played. So when you see the light, we want to play something at that point in time, you have to press buttons below that. And I saw this, I went home, and I thought I would like to have something like this, but like this collaborative element of playing with music and programming music with other people, but online. Like we don't have to all be in the same room. This would have done numbers like 4 years ago, trust me. I wanted to have something like this, so I started building, and here's what I'm going to show you. I know I'm not, front-end design is not my passion. Okay, CSS isn't either, and this is still very, very experimental. But I think it's nice to try. I'm not going to. Okay, I'm going to open this in a new tab also. Okay, of course I have to go out of full screen. Okay, that's not working. Wait. No, wait. Something is, of course, misbehaving. Let's pretend that did not happen. Where is my goddamn slide? Okay, here. So, let me put this next to each other. Demo effect. Okay, so on the left, we have the leader. That's going to be like what I will be playing music from. And on the right, we have just a normal window. And this is connecting over WebSockets using Calico and all that. I'll just show you the multiplayer aspect for really quickly. I can play something from here, and this is using currently the MIDI instrument. There's also another one here. So it means that the input will go to my external synthesizer right here through the MIDI protocol, and that will be played on this device. It will go back to my computer just for playback, but this might as well be a huge synthesizer on the wall. So let's play it. You can see I don't have volume control, but when it's playing, you can see that the red is showing like what's playing at the moment, and yeah, that's it. I can change it from this other window. Like I can clear this whole line. For this line, it's gonna be okay. Some lags here, yeah. So that's connecting over WebSockets. This is of course an incomplete demo. There's still much to be done, and this can be much better. This can work globally potentially. But yeah, I think it's pretty cool. What's also cool is that we can change to a different instrument. It's called Sounds of Scala. It's a library from Paul Matthews. He's doing talks on conferences these days. You should check them out, by the way. He's a literal rock star, and I don't take that lightly. So now, this is actually being synthesized by the browser, like using just browser APIs. What else can I show you? I can show you like you can upload different songs. You can change all these like while it's playing. Let me. And I'm just controlling the aspect of how it sounds on the synthesizer. This is just controlling what gets played. Now, we can also play live here using my computer keyboard. Okay, it's not very loud, but... And yeah, let's say we want to start from scratch. Let's just make something. So I can clear all these tracks, and let's say I want to have C4 here, 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 and here. Let's play that. That's gonna be our kind of beat kind of thing. Let me change the sound as well. And yeah, I should be able to play and record onto the second line. Let's see. It's not on beat, but it still has like a cool effect, right? Doesn't it? Let's do something else. And now we can just play, with our sound. And I can still play on top of this. Okay, accidentally I recorded into this. Let's try that again. And now we can download this again, make more songs. Let me just play some others that I've made before. We're almost out of time, so I'm done. This is what I wanted to show, really. Summary of the whole talk. Resources and streams are powerful constructs. Music is also amazing, but we all know about that. And these are the same constructs that we use and the same patterns that we use on the backend when we're building things with FS2 and class effect, and they compose very well with each other. So whatever you learned here, chances are you might be able to apply some of that in your day-to-day work if you work with these kinds of things on a daily, and even if you don't do front-end. So yeah, I encourage you to learn more about these. You can find the slides on my link tree. I'll post some links on Twitter as well. Yeah, I recommend you check out the FS2 docs and Aquascape, which are some new docs by Zaina Bali, another great speaker and organizer. And yeah, okay, this is all I have. Thank you again. Thank you to the organizers, and I'll be here for questions later.
Thanks a lot once again to Kuba Kozłowski. As he said, he's here. You can catch him over coffee, and if not, if you're online, you got all the details. So be sure to reach out.